So David has an extensive background in engineering and management for over 24 years. He currently leads a team at NIST, focusing on channel measurement and modeling. And prior to his role, he also served in various positions at NIST. And before joining NIST, David worked as a senior engineer at Raytheon Technologies. So please join me in welcoming David for the next presentation.
Hey, thank you very much for that introduction, and I'd like to thank Dr. Dutta for kindly inviting me here to provide some brief remarks about the National Institute of Standards and Technology and the work that we're doing in open radio access networks. All of this takes place in the context of the mission of NIST, which is to promote innovation and industrial competitiveness for the United States. And that is by advancing our core competencies in measurement science, standards, and technology. So NIST consists of a number of laboratories that run the gamut from physics to chemistry to materials science and many other STEM disciplines. Our group is located in the Communications Technology Laboratory, which is split about 50-50 between facilities in Boulder, Colorado, where our headquarters is located, and in Gaithersburg, Maryland, where my division lives. And the two divisions in our lab that are most directly involved with ORAN work are the Spectrum Technology and Research Division in Boulder and the Wireless Networks Division in Gaithersburg. What we're primarily focusing on are a number of key challenges and opportunities that involve quality and performance of ORAN networks, multi-vendor environments and the challenges that those pose, issues related to security and resilience, along with colleagues of ours in the Information Technology Laboratory at NIST, who are very well known for their extensive work in cybersecurity, as well as algorithms for the radio intelligent controller, or the RIC, both the near real-time and non-real-time versions of those. And just to briefly mention that in the case of quality and performance, we're looking primarily at key performance indicators because of our nature as a metrology lab, in order to ensure that people who are testing these systems can answer the key question of, do these meet or exceed the performance of single vendor systems? Because if they don't, then that's going to be a major problem for deployment or competitiveness of this architecture. So why NIST? Well, NIST has, the Communications Technology Laboratory was formed in 2014. Before that, the Information Technology Laboratory has been around since the 1990s and has done research into a broad range of communications technologies, from optical networks to wireless systems. So there's a lot of expertise that we can leverage there. Our work also supports ORAN's disaggregation goal. Which again opens up the field to competition and enabling varied solution and vendors for each part of the architecture. What we aim to do with our research is to lower the barrier to entry and achieve vendor diversity. And because of our nature also as a non-regulatory government agency that's part of the Department of Commerce, we also are looking at making testing suitable for government use of ORAN. That's a slightly different focus than the ORAN Alliance, but it's an essential one. And we also believe that if we're successful in that realm, that can help stimulate adoption of ORAN in other sectors of the economy as well. And the adoption of new technologies is at a critical juncture. As I said, the performance has to be on par with existing monolithic vertically integrated systems to be commercially viable. But we believe that by providing tools to improve integration and optimization, and those tools that we provide, we make available to the public. We have things that are available on GitHub, for instance. We have data sets that we're making available through the NextG Alliance. We hope to be able to speed up the process of integrating these systems. So we have four major research thrusts into open source platforms, advanced security, interoperability between systems, as well as AI and machine learning. And to that, and we're also looking at partnerships that we've developed. We've been a member of the ORAN Alliance since 2022. We participate in select working groups and focus groups, which I will highlight in a couple slides. We're also engaged in a community of interest with other federal agencies, such as the FDA, the FCC, DoD. to educate people in those agencies, share lessons learned related to deployment and testing, so that we can provide additional benefits to the ORAN research community. We've been involved with the Telecom Infra project since 2017, which contributes to the interoperability working group in the Open RAN Alliance. And we are involved in several working groups in 3GPP, such as Radio Access Network 1 working group, where we have been developing 3GPP standards that impact 6G, propagation measurements that we've been performing, and models for joint communications and sensing applications. The facilities that exist in both the Gaithersburg and Boulder labs are divided such that most of the physical measurements, such as setting up antennas in anechoic chambers like the one that's depicted in the figure on the right, take place in Boulder. Gaithersburg does some network emulation and simulation work, but a lot of what we do consists of doing modeling and processing of the terabytes of data that our colleagues in Boulder generate for various channel modeling applications, network emulation applications, and so forth. So we have several test beds that are located in both Gaithersburg and Boulder, emphasis on Boulder. Then we are able to examine virtual and physical network deployments. We can reconfigure these things. They're highly flexible for specific scenarios. Rapidly deploy communication systems, including carrier-grade base stations. I was actually in Boulder last week and got to see a base station on a tripod in the chamber on the right. Also do comprehensive signal analysis in this chamber and also in a reverberation chamber that's right around the corner from it. So we're involved in 6 of the ORAN Alliance working groups. These are the ones that are highlighted in green. And these range the gamut from use cases and architecture to test and integration. I'll just quickly go through some of our interactions with these groups that have been happening over the past couple of years. The test and integration focus group, one of the other group leaders in my division, Doug Montgomery, is a voting member. And our focus has been on the quality and completeness of the ORAN test specifications and also the Open Testing and Integration Centers, or OTIC, program management. In addition to improving trust and confidence in the OTIC badging processes, which helps with site security, we're also evaluating the security test scope and quality for the purposes of our fellow federal agencies. In Working Group 11, which focuses on security, we have several people who are looking at aligning ORAN's specifications with NIST and U.S. government security recommendations. For example, the Alliance has stated that they require a zero trust architecture in line with NIST Special Publication 800-217, which is part of the well-known Information Technology Cybersecurity 800 Series Special Pub Series. And in addition to helping to develop a ZTA for ORAN, we've also been looking at security for artificial intelligence machine learning systems and making sure that the technical report that comes out of that working group is aligned with the NIST Artificial Intelligence Risk Management Framework, or RMF, which version 1.0 of that was released last year. And also making sure that OCloud and service management and orchestration security is aligned with NIST guidance and enduring security framework recommendations. We have a couple of people involved in the cloudification and orchestration group, which is also, and our activities are also focused on security recommendations for federal agencies, looking at network slicing in particular and evaluating security testing, again with a focus on assisting other federal agencies. We've also been involved in both the non-real-time and near-real-time RIC and A1 and E2 respectively interface groups. We have 2 people participating in that who are looking at specifying the architecture and functionalities of the RIC and of the interface, and looking at the workflow associated with machine learning systems for those controllers, including the AI lifecycle and elements of the deployment. And I'm just going to do a quick example of some of the work that my colleague Sunil Gopal has been doing on that front, developing what we call the PROSAS, or Proactive Spectrum Adaptation Scheme Framework, which aims to dynamically allocate resources between different networks that might be sharing resources. This process consists of data collection and then using that data collection to build models to do demand prediction, and then using the demand prediction models to do dynamic resource allocation that's efficient, as opposed to simply nailing resources up and then potentially not using all of them as the demand fluctuates. The way that we did the data collection last year was that we, at the Gaithersburg site, we compiled an extensive data set of scheduling information that we did over the course of 2 months using Band 4. And from that, we were able to extract physical resource block, or PRB, demand levels that we recorded at various levels of granularity. So the graph at the top shows hourly demand levels averaged, and the much more fuzzy graphs at the bottom are for minute level demand levels. While we were able to collect data only for LTE, we generated synthetic data for new radio by using time-GAN, which is a form of generative adversarial network, to produce synthetic data. And I think that is another potential tool that can be of a lot of assistance to the community, developing the tools for researchers to develop synthetic data, because it's often difficult, if not impossible, to get actual network data unless one has a CRADA or some other agreement with network providers. And from that, we were able to come up with a scheme for deploying our system within the ORAN architecture. And the paper that my colleagues, Dr. Gopal, presented at ICC in Denver back in June gets into more detail here. But we basically discussed how the collected data can be routed using our apps within the RIC to then actually implement some algorithms to continuously record the demand levels from the various elements of the network, and then dynamically allocate resources for the next time interval. So that, again, we achieve the goal of allocating resources, but not too many resources, so that other resources are in reserve for other functions. In addition to that, we have been involved with WG1, looking at the overall architecture. We've been looking at the Open Cross-Haul Working Group, looking at the transport network. And also, we have several people involved with the Next Generation Research Group looking at future architecture. And as I said, looking at issues like how to implement joint sensing and communications, which is a current study item in 3GPP in the context of an ORAN system as well. So we're also developing an open 5G testbed. The objective there is to establish a research sandbox of sorts that would support the ability to do experiments in partially emulated environments at both the component and the subsystem level, which would let people do experiments with lots of different deployment scenarios for ORAN systems, and more importantly, enable people to do interoperability testing of implementations of 5G components, including swapping systems out and testing testing variations on various deployment architectures. And this would also allow our stakeholders in the industry to evaluate industry-driven test methods and tools as well. So what we plan to do next is to continue and expand our collaboration with other federal agencies. This involves participating in government ORAN Alliance engagement calls that are currently being organized by MITRE. We have a partnership with DHS. We've developed a draft memorandum of understanding with the Defense Department. And also we are supporting the NTIA's Wireless Innovation Fund as well. We will be increasing our engagement, which is already quite extensive, as you've seen, with the ORAN Alliance, the IEEE, and TIP, particularly our colleagues in Boulder, and increasing engagement with other standards organizations as well, and leveraging our testbed to do system evaluations. And with that, I will stop and thank all of you for your time. Ashutosh, we have a question.
Question,
back.
yeah, sure.
I can probably speak loudly
Okay,
enough.
I can hear you.
With respect to your 5G test bed, if I were a hardware manufacturer, if I were a software manufacturer, I might be very excited about your lab. And I would hope to see other OEM equipment and software. But then there's what happens to the data, how private are things, if I'm, networks or emitters. How safe can I feel about what I'm testing and what equipment's there?
Okay, I'll repeat the question for the people online. So the question is, if somebody comes and uses our facilities to do testing, how safe can they feel about the data? While I'm not directly involved with the 5G testbed, I can say that we have a long history of testing vendor equipment for public safety communications applications, and usually that has involved CRADAs or other agreements that emphasize that the tester has ownership of their data, and we don't share that data with other people.
Would I get block time so I was the only one in the lab, or would there be other people there?
I can ask other people that question because as I said, I don't directly interact with the test bed, but what I can say is that we've always tried to be as accommodating as possible to people's needs. And so if people have concerns, we try to take those into account as much as possible. But I can ask, and then I can get the answer back to you.
Thank you. You also have another cybersecurity test bed, right? I remember there is cybersecurity excellence. Center of Excellence.
Yes, we're associated with the National Cybersecurity Center of Excellence in Gaithersburg, which is just around the corner from universities at Shady Grove. And they do a lot of work with industry to improve the state of the art. Yeah.
Excellent, that's good to know. You do a lot of good work.
Well, thank you.